Hello, I'm Tobias and today I wanted to tell you something about our newest development, Visalys bulk flow, and the development process right behind it. So I'm currently head of research and development at Kettenbach Dental, and I joined the dental business around about 8 years ago. So I do have a bit of expertise in dental restoration materials and all the techniques and the development processes behind it. So besides myself, Professor Roland Frankberger was also working on this project with us. He was mainly processing the external studies on the product. So he's a member at the University of Marburg, and he's very expertised in restoration materials as well as adhesive techniques. For the clinical outcome, Professor Klaus-Peter Ernst was doing some clinical cases for us. He's also well known and is an expert in restoration development, restoration techniques, restoration materials, and adhesive technologies. So first of all, what was the idea behind it? When we were thinking about a new product in the field of restoration materials with Visalys bulk flow, we wanted to make sure that we do have the scientific evidence for a material that then can be a good material in the clinical outcome. So if you think of a bulk filling material itself, it's most important, or the first thing we are thinking of, is the shrinkage force, of course. So when talking about the bulk flow material, you are thinking about huge cavities up to 4 millimeters. And if you have such deep cavities, the shrinkage force is mainly important because the deeper the cavity or the more material you're filling in, the higher the shrinkage itself is. So when talking about the origin of shrinkage, if you want to have a look at this, you can have to think about the paste-like consistency that you are filling inside of the cavity. And this paste is hardening through the light curing process, and due to this hardening process, the monomers are becoming polymers. You're starting the polymerization, and therefore you are getting the shrinkage of the whole product. We are not only talking about volume shrinkage, that's very well known, but we are mainly talking about the shrinkage force, because depending on the hardness of the material, you can have a very high shrinkage force even if the volume shrinkage isn't that high, for example. So you have to really look at the forces that are applying on the cavity walls. So after a very high number of formulations, we found a composition that is very low in shrinkage, as you can see here on the left. This is due to a very high filler content, a good distributed filler sizes, and due to the monomer matrix. So it's very important to have a monomer matrix that is not high in shrinkage. And that's what we could see here. So if you see, if you have a look at other products, they are much higher in shrinkage force, or can be much higher in shrinkage force. So a low shrinkage force was the first thing that we could achieve. And this low shrinkage force should, in theory, lead to a good dentin adhesion. So if we look at this setup here, it's made by Professor Roland Frankenberger at the University of Marburg. And you can see a very deep cavity, this whole 4 millimeters that is possible with a bulk flow material. And you can see these this cavity walls here. And in theory, if you do have a too big shrinkage force, then these could be so-called pretest failures. So even 0 of adhesion, 0 megapascal of adhesion in this case. This could be in theory if you do have a too high shrinkage force. And as you can see here, this very big cavity has a very high C factor, and therefore is really the worst case for restoration material. So if you now have a look at the results of the dentin adhesion, you can see that this very low shrinkage force indeed leads to a high dentin adhesion, as you can see here on the left for Visalys bulk flow. So the theory is approved, so to say. So if you're now thinking of the low shrinkage force and the high adhesion to the dentin, you can now think about the next step, and this is margin quality. So what was tested next was the margin quality and abrasion of the material. You can see here extracted human tooth that were prepared with a cavity and filled with Visalys bulk flow. And after around 1 million cycles of chewing simulation and around 25,000 cycles of thermocycling, we had a look at the abrasion as well as the margin quality. You can see here a picture of the margin. So in theory, there should be no margin between the composite material and the dentin or the tooth structure itself. Well, that's the best way a material should perform. On the other hand, we also had a look at, as I said, at the abrasion. So the lower the abrasion, the lower the wear of the material. So just one remark on this. So if you have a low shrinkage force and a good adhesion, you should in theory also have a good margin quality. That's obvious. So if you have a look at the first results for the margin quality on enamel, you can see that most materials do have a more or less high quality of margin on enamel, but Visalys bulk flow has one of the highest values. It's not that hard to get a good value on the enamel surface, but it's even harder to get a value, a good performance on the dentin part of the tooth, as you can see on the right hand side. So what's the process behind the dentin? So in theory, or even in practice, after this chewing cycles and the thermocycling, you do get the degradation of the dentin. So it's very hard to get very nice results between this interface of composite and dentin. So something around 70% is the best that you can get. And you can see that Visalys bulk flow, in this case here, has something around 70% and is therefore very good even on the margin quality itself. If you now have a look at the abrasion values, you can see that our material performs as good as very established bulk fill materials, as you can see here on the left-hand side. And on the right-hand side, there are examples of products. They are even higher in abrasion, for example, the class ionomers. So after all the technical data that I was showing to you, I now want to talk about the color and appearance and the handling of the material. So first of all, our material has just one shade for all the different Vita shades. And it has, as it is a bulk filling material, the 4mm polarization depth that is necessary for such a material. But at the same time, due to a special filler technique and a special pigmentation technology, we can achieve a very high opacity at the same time. So a high polymerization depth and at the same time a very high opacity. So here you can see a huge number of different colors on artificial teeth. So we prepared cavities in all of these artificial teeth, 4mm in depth, 3mm in diameter, and filled all these cavities with Visalys bulk flow. So just one shade for all of these different colors. And as you can see, the color adaptation, so the appearance of the bulk flow, is very nicely adjusted to the surrounding tooth color. So after talking about the theory, I'm now coming to some clinical cases, some clinical outcome that I also wanted to show you. So in this first case, I wanted to show you a very small cavity on a premolar tooth that was prepared and afterwards filled with Visalys bulk flow. And you can see at the very last picture that the appearance of the material is very nice, and you can't even see the restoration at all because of the nice adaptation of the material to the surrounding tooth color. So another case that I wanted to show you is this one here. So once again, a cavity with a caries inside it, and it was nicely prepared and then filled with our material. And what I wanted to show you here is the nice adaptation of the material. So our material, Visalys bulk flow, is a flowable bulk composite. So it is flowable, but at the same time has a nice consistency that it doesn't slump around if you are on the upper tooth, for example. So it has a nice flowability to adapt nicely to the cavity walls, as you can see here in this radio image on the right hand side. So here we have another case where the restoration was placed next to a gold crown. And as you might know, if placing restoration materials, especially bulk flow or bulk materials in general, behind this or beside a restoration that is very high in opacity or very high in color, so to say, it's very, or in some cases you can see a grayish appearance of the resulting restoration. As you can see here, we do have a nice result even placed in contact to the gold restoration, so it doesn't look that grayish or something like that. So once again, a very nice result of the appearance of the material due to the higher opacity, so you cannot see the restoration next to it. So one last case that I wanted to show you here is a bit of a deeper cavity that was also filled with Visalys bulk flow. So you really need the 4mm of polymerization depth. So after filling the material, you can see once again a very nice appearance of our material. And you can see this restoration here has a very high content of the occlusional part. So very high in wear in general, but it fulfills all the requirements to achieve this restoration as well. So after the development process of Visalys bulk flow, it now proves itself in clinical cases, as you can see. So we have this very nice process from the scientific background, the development process, up to the clinical cases that I could show you in the last slides. And hopefully I could give you some insights on this process itself. Yeah, thank you very much.